Hi, I'm Brian, and this is the Bayport Glass Distillation Unit.
The Bayport Glass Distillation Unit is designed to separate a 50-50 mixture of isopropyl alcohol and water with a few drops of food coloring. Alcohol boils at a lower temperature than water. When the mixture is heated, the alcohol vaporizes first, rising through the 10-tray column, where it condenses and is collected as the distillate or overhead product. The water and food coloring with higher boiling points remain as the bottoms product. This same principle is used in refinery operations. For example, lighter components like propane are separated from heavier components like butane using differences in boiling points. The Bayport GDU provides a visible, small-scale example of the same distillation process that happens every day in towers at refineries and chemical plants. Let's power up the system by turning on the main switch and starting the cooling water pump. Next, we'll open the 3 needle valves on the cooling water manifold to establish flow through the unit. This is a critical step. The active chiller provides the cooling needed to condense the hot vapors that will form later in the process. Now that we've established a cooling water loop, let's start the unit charge pump. This will pump the solution of alcohol, water, and food coloring from the charge tank over to the reboiler and the bottom of the distillation column. After the reboiler is filled at least 70% and the heating element is fully submerged, we can start the reboiler and adjust the output to around 80%. We will adjust the reboiler output as needed to maintain a bottoms temperature of around 185 degrees. Next, we can see the vapor rising through the distillation tower. This movement is known as vapor traffic. As the vapor passes through each tray, a thin layer of liquid holdup remains on the trays. This creates a pressure gradient and maximizes contact between the rising vapor and the descending liquid. The lighter, more volatile alcohol continues upward in vapor form, while the heavier water, which hasn't reached its boiling point, flows back down as a liquid. But here's an interesting question. What if we increase the reboiler heat enough for the water to boil and turn to steam? How would that change the flow and separation in the tower? Next, we'll start the bottoms pump and open the flow valve. The flow is measured using a rotometer. As liquid moves through, the ball lifts off its seat and floats in the viewing tube, indicating the flow rate. Sometimes air pockets in the line need to be purged to get an accurate reading. If air remains trapped, it can disrupt the liquid flow and cause the rotometer to give a false or unstable indication. The bottoms pump draws liquid from the base of the tower and sends it to the bottoms product tank, where it can either be collected or returned to the charge tank below for another pass through the system. The alcohol vapor has worked its way up the column and hits the cooling coils in the overhead condenser, where it cools down, turns back into a liquid, and collects in the overhead accumulator. Now we'll start the reflux pump. It's got 3 valves, each with its own job. The first valve sends liquid back to the accumulator to keep the system circulating. The second valve sends reflux to the top of the tower. That cools the tower and helps separate the products more cleanly. The third valve sends the finished product to the overhead product tank. We don't open that last valve right away. We need to make sure there's plenty of liquid in the accumulator first. That keeps the system stable and the separation steady. Thanks for watching, and great job following along. The best way to build real confidence with process equipment is to get hands-on. Schedule a time to come in and run the Bayport glass distillation unit yourself. Always prioritize safety. Wear proper PPE, follow the written procedure step by step, and stay alert to how the system responds. Once the unit is running, collect and measure your overhead product. Use one of our refractometers to check alcohol content and product purity, just like operators do in industry. This is where classroom knowledge connects to real-world process operations, and where your skills start to truly take shape.